As we perform this installation, you will see how the doors should be adjusted and how you can get maximum performance from any closer you install, not just floor closers. Let's go to the main entry doors and begin our replacement of the Rixson Q27 floor closers that were originally installed a decade ago. We'll begin by troubleshooting the original problem. When you are troubleshooting a door installation, you need to review the entire opening. First, where is the door? How is it used? And what is the environment? This is important to make sure that a product was properly specified. You shouldn't use surface closers, for instance, on very high traffic doors, not unless you think of them as disposables to be thrown away and replaced every few years. Is there anything special about the location of the door? Metal doors that are in direct sunlight all day may swell or distort. Many a lock set or exit device has jammed or opened mysteriously in the morning, only to function normally later in the afternoon, when the sun went to the other side of the building. Wind conditions and stack pressures from heating and air conditioning are also a significant factor in this first step of troubleshooting. In this case, the designer wisely picked a floor closer for these front doors. Floor closers are more efficient than surface closers because there are fewer moving parts to waste energy. Think of a surface closer with its arm pulling the door closed. With a floor closer like this, the arm is part of the door assembly and is attached directly to the closer spindle. The architect's selection gave him a closer that wouldn't be difficult to open and would remain inconspicuous to his design. Look at the physical size of the door. This door is 2¼ inches thick, 3 feet 6 inches wide, 9 feet tall, made of metal. We estimate these doors to weigh around 250 pounds each. This is important because we still want to make sure the hardware on the door is properly specified. The 27 series floor closer can handle that weight without a problem. The designer specified 2 M19 intermediate pivots because of the height. This maintains vertical alignment and ensures good performance. Later, you will see how the M19 serve an additional function of balancing the door on the closer itself. Though essential to alignment, the M19 carries no load. The Q closer used in this initial installation is intended for 1 3/4 inch doors only. This is the improper product selection mentioned earlier, and it's a deal breaker for a warranty installation. When the contractor had to buy special length screws to install the arms to the doors, it should have been a signal there might be a problem. He obviously completed the task anyway, and the result was an adequate, if not correct, installation. The fact that the closer lasted 10 years is a credit to the product. Check the overall installation. The gap between the door and the frame seems to be consistent all around. There is no drooping from broken top pivot reinforcement welds. There are no drag lines on the threshold from a sagging door. The intermediate pivots have gaps between the leaves. This indicates that the weight of the door is being borne by the arm and floor closer, as it should be. Now, test the action of the door. The complaint on this door is that there is no control of the closing action, no differentiation between closing and latch speeds. The door cannot be made to close more slowly or more quickly. While opening the door, we notice that we hit a strong back check at 70 degrees. The closer is acting as a dead stop for the door 20 degrees too soon. Doors such as these that have heavy traffic at times will be pushed against the back check port. This can cause damage to the spindle assembly and could cause other valve problems. Next, we make a few attempts to adjust the closers ourselves. It's not that we don't believe what we've been told about the closing action, we just want to make sure that the diagnosis is correct. The Q arm is surface applied. The M19s and 180 top pivot will hold the door in the opening. Well, that sounded simple, didn't it? Let's go from theory to practice. Tighten all valves down, closed. Go to the outside of the door. Remove the decorative arm cover. Go to the face of the door on the inside. Remove the 3 arm mounting screws. Loosen the arm attaching screw. Insert straight blade screwdriver into the torque washer on the spindle of the door closer. Use a screwdriver to turn the spindle toward the opening. This will pull the arm from the underside of the door. Once the arm clears the door, lift it off the spindle. Swing the door open 90 degrees. And remove the threshold cover plate. Whenever thresholds are used with floor closers, it is very important that non-standard thresholds are used. A standard threshold would run the full width of the opening in one piece. With floor closers, they must have at least 2 pieces, one that covers the closer, the other for the balance of the door width. A standard threshold would mean complete removal of the door. Now we can see what kind of mess we'll be dealing with. Since Rixson has gone to Cycle-Lac cement cases, the rust of the body doesn't bond with the disintegrating metal cases. Remove any filler pieces. Remove the 4 screws holding the body in the cement case. This may be difficult, and they may need to be drilled out. Picking up the closest edge of the closer body, lift it up and away from the door edge and out of the cement case. The fact that the closer sits farther in the ground than most floor closer installations is unique to the Q closer. You can see how helpful it is to this replacement. Clean away any debris in the bottom of the cement case. Check the replacement body. Does it look exactly like the one you replaced? Is the spindle the same height? Measure from top of body to top of spindle. Are the valve quantities and locations the same? Be aware that closers are shipped from the factory and from repair agencies with valves tightened all the way down. This allows you to work on the closer without concern for being hit by the closing door. Bank closer under the edge of the door and set in cement case. Even though this wasn't the best model closer for the installation, we must replace the old product with the same product. Otherwise, the doors would need to be reworked. Replace the closer screws into the cement case. If you drilled out, then you need to retap for 1/4 20 screws. Replace any filler plates you removed. Replace the threshold cover plate. Now, close the door. Install a torque washer on the spindle. Put your screwdriver back into the torque washer and turn approximately 90 degrees. Attach the arm to the closer spindle. Do not tighten the set screw just yet. Open the door so the face meets the arm. Replace the 3 arm mounting screws. Now, we're going to show how the M19s can guarantee a proper floor closer installation. Remove the caps from both M19s. Use a straight blade screwdriver to turn the pivot screw until both leaves of pivot are snug. Use the furnished shims to fill the gap under the arm. Back the screw off to allow the door to settle down. Repeat with the other M19. Note that the leaves should no longer be tight together. The door is now resting on the arm and spindle. Next, you'll tighten the arm set screw. When you think you have it tight enough, tighten it again. Open the door and tighten it again. Open the valves and tighten the arm attaching screw again. Now, let's adjust the closing, latch, and back check valves. Remember that Rixson floor closer valves are very sensitive. A half turn can have a dramatic effect on the door closing action. The closing and latch valves are speed controls. They do not make a door have more force. Start with the closing speed valve. Keep adjusting until you have the speed you're comfortable with. Latch control should be slightly faster than closing speed if the door needs to overcome a latch bolt engaging in a strike. If the door has a push or pull and no latch, then the latch speed should be the same or less than the closing speed. This keeps the door from loudly hitting the frame stop. These doors have panic devices and do have to enter a strike. Even though the devices are dogged for performances, the better way to adjust them is with a faster latch speed. Now that we have the closing speeds taken care of, let's look at the back check valve. Back check is a resistance that comes into play at around 70 degrees. It is supposed to keep doors from swinging backward too quickly, either by a person exiting or from gusts of wind. Since these Rixson floor closers have a positive dead stop at 90 degrees and an overhead stop as well, there is little chance that these doors could be affected dramatically by winds. So the adjustment for the back check should be enough to slow the movement backwards, but not to dead stop the door. Now, replace the arm cover and screw. Well, that just about does it. Less than 15 minutes on the real-world clock. By replacing the original product with like product, design has not been compromised and quality not diminished. For over a century, Rixson has partnered with architects to create buildings that are functional and beautiful. As a material supplier, sales representative, or service technician, you have an obligation to support that original intent. To do anything else would be a disservice to the owner. We hope you find this tape informative and that we have made floor closers a little less intimidating.